So my name is Ariel. I'm here to talk about service level property-based testing. Thank you all for coming. It's great to see so many friends together again. Let's see, who am I? I'm software engineer, as most of you. I worked in a few Clojure shops before. Now I am working at Brex, not representing them here. Don't work at Clojure anymore. I have a lot of slides and some live coding for 10 minutes, so I will move super fast. It all started a few months ago. I was working on one of my pet projects. I actually decided to build a new thing and start building this smart mirror. The idea was to show my calendar, some tasks, plants that I should put water, not avoid them to die, this kind of thing. And after just a couple of days working on that, I thought, distributed systems are hard. I usually talk that every day. And the problem is nodes will behave weirdly, database will die, messages will come out of order, or don't even come at all. So we actually know how to deal with that. It's something that we do every day. We have hit tries, we have timeouts, we have consensus algorithms, we have core reads and writes, we have all these tools. It usually works pretty well, but how do we test this? I mean, most of the places I have worked, they do one of these three things. Or we manually write tests at integration or unit level. So we have a repetitive boilerplate for each one of these test cases. If this dependence die, if you have this kind of partial failure, this should happen. And we end up with a huge number of tests. It's very hard to maintain, costly to update. An alternative thing that I saw is to rely on end-to-end tests. So I have a few basic end-to-end tests that basically cover the most important features that we have. But the feedback is really slow in this case, at least on my experience. And it's usually flake. Failures are super hard to debug and expensive to maintain. Nubank actually has a really good article about that. The third most common approach I saw is don't test. Why bother, right? It's really hard to do. So what if we could actually deterministically and automatically generate test cases that simulate failures in each one of our dependencies, and we just describe what is the expected behavior of the function, or in your case, the service, for all the possible scenarios. And this is actually a solved problem. This is called property-based testing. We have been doing that every day. So I thought, while building my Smart Mirror API, I might be able to do that. And I have a super draft prototype. It's very ugly, but I think I'm sharing that with you, and we can, I don't know, share this idea and improve that together. So let's move here. I show an API here. You can read it. Okay. We have this API. You have some endpoints here. And let's look at this one. Need water. What does that do? We basically call this controller and return a HTTP 201. And what does this endpoint do here in the controller? It receives a database, HTTP client, config, and some data. It first gets this token from the config. The config is basically, it comes from the system. Don't need to worry about that. You read the config, get the token. FCM means Firebase Cloud Management. It's basically the tool that I use for push notifications. We go over the database. We get our plants that need watering today. And we send a push notification. So it's an HTTP request. All right, that's good. If the Firebase returns forward tree, we return a forbidden for the client. Otherwise, we return a bad gateway, and we have to debug to see what happens. After that, we save the notification in the DB. So we persist notification entity, very simple. And okay, that's good. It's very simple, nothing interesting, very trivial actually. But I think it represents a thing that we do in our day-to-day jobs. And most interestingly is how could we test this? And here is the thing. I developed this tool, let's say like that I measured quick check with state flow. So it's a little bit, it's not my best code, but it works and it's deterministic. We run dev test with quick check. So we basically run it 100 times or whatever times you want. It will receive a seed that you can replicate the test case. And this is basically property-based testing. So I generate sample data here. I start with as a super basic test, creating a request just to create a plant that needs water. When I add some basic mock response here, so the FCM endpoint should return a 201, something very similar of what it would return in the real life. And so far, it's okay. Nothing super interesting. But things get more interesting from now. When I make the request from my own endpoint, so I'm testing this endpoint, plants need watering, I have this weird function here, match case, that actually does pattern matching with the response that we get and the system state. So if no faults are injected, it should work as expected and returns a 201. HTTP success, that's great. However, if the FCM returns unauthorized, so I have this auxiliary function here, so the server should return a forward tree for the system. It's the case where a fault is injected in the HTTP response of one of the dependencies. If something else happens with this FCM endpoint or the Firebase endpoint, this should return a 500. And we have other cases here. If the database, here I'm using Datomic, if the database has a fault injected in the query, so I use the atomic memory, but I am manually injecting randomically. So everything here happens randomically, but using the seed that we give so we can reproduce. If a fault is injected in the database, in the query, this should also return a 500, and in the transaction, it's same thing. Otherwise, expect to return 201. And we can actually extend this test case for more interesting scenario to see, okay, so far I can validate the response of my server, my endpoint, based on possible faults that I'm injecting in these dependencies. But how do I check if the operations that it performed? And with some auxiliary functions as well, we can do that. So I can say, oh, if the database if there was a fault during the query, it might be, I don't know, timeout in the database or something like that. We could actually specify, but to keep it simple, I just put it as a generic fault. If a fault happened in the database, then the FCM, the Firebase endpoint, shouldn't be called. And I can check if we call this endpoint, I can check the state of the system to check if this endpoint was called. If not, we just check if it was called. Similarly, we can do the same thing above here. I don't want the transaction to be written if the endpoint was not called. So if the Firebase endpoint was called, it means I assume that the push notification was sent, and then I can check if the transaction was made to the atomic, and if the transaction was made, I can check if that I can just get the data from the DB and check if the plant was right, or the notification is there. So normally, I would do that with 2, 3 distinct tests. And I can put everything together in just one test case and randomically inject the tests. I have this function here that I define which kind of tests, faults I want to inject, and randomically they will be injected in the test using in the system, actually. So yeah, we are out of time. I had other examples to show, but the idea is the same. I have this other example where I get the data from my calendar, so I use the Google Calendar API. I have to check the same thing if the endpoint returns, the Google Calendar returns a 401, 403, something like that, and how my service will behave. And I can actually specify these things with just one test and inject the test randomically, make it happen easily and quicker than doing that manually. And that's all, folks. We don't have any time more. Thank you.